Hey, here we're looking at podcast 1.3. This is first of two podcasts for this standard. And here we're going to be taking a look at the role of enzymes in biochemical reactions. We're also going to take a look at things that will affect how enzymes work. So you will be able to understand that enzymes are proteins. So we just talked about proteins and what they are. We'll recognize enzymes as biological catalysts. Understand that enzymes are only going to work under specific conditions. They need to have certain temperatures and pHs in order to do their jobs. And we'll be able to look at a chemical reaction, what it is, what the reactants and products are in a chemical reaction. So here are some of the essential vocabulary words that you're going to see throughout this one, and some of these you're really going to need to pay attention to as we go through. So let's start with a chemical reaction. Anytime we're talking about a chemical reaction, it's basically changing chemicals. We are taking one set of chemicals and changing them into a different set of chemicals. You cannot change matter. You can't create it, you can't destroy it, but you can rearrange it. So basically the configuration of the elements that are in the molecule is going to change, but not the kind of elements that are there. So you can't change oxygen into nitrogen. It doesn't work like that. But you can change what oxygen is bonded to. So many chemical reactions that happen are going to require energy to occur. And then there are some chemical reactions that are actually going to release energy when they happen. So depending on the type of reaction we're looking at, a lot of the reactions that happen in the human body actually require energy to occur. And so that's why we have enzymes to help the process along. So a little more on chemical reactions. When we talk about a chemical reaction, the reactants are the molecules that are going to get changed in that reaction, so the things that are going to actually be physically changed. And the products are the new molecules that are going to be made by the reaction. So basically the way that we say this is the reactants are going to yield the products, and we use this arrow symbol here to show the direction of the reaction. Sometimes you can see that arrow go forward and backwards, and that means the reaction is reversible. Okay, but in this case we have two hydrogen molecules and an oxygen, and that's going to make water. So your reactants are the hydrogen and the oxygen, and the products are your two water molecules. And if you notice, this is a balanced equation, so we have 4 hydrogens on this side, we have 4 hydrogens over here, we have 2 oxygens on this side, and we have 2 oxygens here, 2 times this one here. Alright, so when a reaction requires energy to occur, we call this energy the activation energy. So the amount of energy needed to start a chemical reaction. Okay, so when you look at a reaction, you have your reactants are hanging out down here, and they want to become the products. But in order for them to do that, they actually have to gain a certain amount of energy before they can get changed over into the products. And that amount of energy that needs to be put in is the activation energy. So it's kind of like a light bulb. You can't just tell a light bulb to turn on. You actually have to give it some energy before it will turn on. That's the activation energy. So reactions work in the same way. So a catalyst is anything that is going to lower the activation energy of a reaction. So by taking the amount of energy needed and making that amount of energy less, we actually end up speeding up the rate of the reaction. So we make the reaction go faster. So if instead of needing this much activation energy, we only needed to get to here, the reaction will happen faster because you don't need to get as much energy. The less energy you need, the faster the reaction goes. So catalysts are going to lower the activation energy, and enzymes are catalysts. So we talk about enzymes. Enzymes are what we call catalytic proteins. So that means that they are proteins that act as catalysts. And remember, we just said catalysts are going to increase the rate of reaction. And what's special about enzymes is they do this and they are not going to get used up. They can be reused over and over and over again. So the activation energy is lowered, and that causes the reaction to happen faster. So that's what I was just showing over here. So here we have our reactants, and they want to become the products. Okay. Normal amount of activation energy you would need to go all the way up the top of this hill and then come back down. With the enzyme, you only have to go up to here. and then the products are made. So it happens a lot faster when you don't have to go as far up the hill. So it's just a way of making the reaction happen a lot faster. And one of the classic examples in the body is when we talk about digesting food. If you didn't have enzymes to help you digest your food, you would take years to digest some meals, whereas instead you can digest the average meal in about 25 hours. So the way enzymes are going to work on reactants that we call substrate. So substrate is the reactants that are used when an enzyme is involved. Okay, so it's just another word for reactant. So substrate means reactant, but only when we're talking about using an enzyme. Another term in here is active site. This is going to be a pocket or groove that's on the enzyme that's going to bind to the substrate. So the enzyme is actually going to have a certain shape, and it's going to allow the substrate to bind in there, and that's going to actually make the reaction happen faster. So I'll show you a visual of this over here. Okay, so substrates are going to end up getting converted to our products. So it's the same as reactants become product, substrates become product, because substrates are reactants. Okay, the enzyme is going to remain unchanged, and once the reaction is done, it's released to find more substrates. So enzymes get used over and over and over again. It's just the substrate that's going to get changed. Okay, so you start with your enzyme and you put it with your substrate. They come together, and then you end up in the end with the enzyme still intact, perfectly fine, but now instead of having substrate, you get product. So this is a visual of what this would look like. So here's our enzyme, and remember I talked about there's a pocket or groove, that's the active site, and here's our substrate, and the substrate actually fits, if you look down here, right into that active site. So that enzyme is going to work just on that one substrate. The enzyme comes together, and then it's going to make the reaction happen. So now you have your enzyme, and you're going to end up with 2 free products in the end. Okay. Enzymes are highly specific. Okay, there's one enzyme for each substrate or set of substrates. So for every type of reaction that happens in your body, there's one kind of enzyme that is going to be used. And the way that the substrate and enzyme know when they can come together is because of that active site. So this site here, the active site where the reaction happens, is designed to fit specifically with only certain substrates. So this substrate will fit in there, whereas a different one won't. So this enzyme will only work on this particular substrate. So they are highly specific. So you'll have enzymes that will break down only certain kinds of carbohydrates, and they won't break down fats or lipids. You have different enzymes for that. So we can say this as an analogy like a lock and a key. Okay, so if you think about your house, you've got a key that opens your door. Your key does not open your neighbor's house, or it shouldn't. It should only open your lock. So just like that, there's enzymes for each kind of substrate. There's one type of enzyme for each type of substrate. So it just makes it so that the reactions end up being much more controlled in that sense. Okay, so here's another example of that. Here we have an enzyme, and there's a substrate. This substrate will fit perfectly in there, and then they can bind, and then this reaction will happen, and maybe this will get divided in 2 or 3, and you'll get your products. Okay, a different shaped substrate will not fit into this enzyme, so a reaction will not happen. Okay, and here is a little animation showing you this again. Okay, so you can see where the reaction is happening. So sometimes reactions are breaking substrates down into 2 products or 3 products, and sometimes you are putting 2 substrates together. So here's the enzyme, and it's got a very intricate active site. These 2 substrates are going to fit there. Once they're there, now the reaction can happen. So basically the enzyme is bringing them together and making the reaction happen faster. If you didn't have that, these 2 substrates would be floating around all over the place and need to meet together by random chance. With the enzyme is actually bringing them together, and that makes the reaction happen much faster.